Yeah, so good morning everybody. My name is Nicolas Meyer. I am responsible for the technical sales as well as the application lab at EMAG Lasertech. I want to say hello from my side. Unfortunately, as you may have seen, I am standing alone in our webinars today. Originally it was planned that one of my colleagues is taking care of the moderation as well as of the questions you may forward to us. So I will today try to take care of the whole content, which means I invite you, definitely feel free to forward questions during my webinar, and I do have a tablet in front of me, so I will also see the questions during the webinar and I will try to answer them as good as I can. If not, then I will definitely take the chance and answer the questions later on. Laser welding of large components, that's the headline of our today's webinars, and I want to take the chance and give you an overview about what EMAG Lasertech is doing in this regards, which means especially for sure truck components as well as agriculture components, or also in general construction vehicles. Meaning we do have a very huge variance of different applications, and today I want to give you an overview about what EMAG Lasertech is doing in this regards. We first of all definitely want to start with a very nice application for truck differentials. As you see here on the left picture above, there's a comparison between a truck differential and a passenger car differential, so just to give you a feeling in regards to the size. And one of the reasons why we are having this webinar today is that right now, currently, we are having one very interesting and important line standing in our plant in Heubach, and I definitely invite you hereby also to visit us in Heubach to have a more detailed look into this line, and this is why I also want to start with this line. So this line means we are having an ELC 600 machine. This machine is developed for truck differentials, and this machine is focused on let's say components which are pretty heavy, pretty big in size, and we decided to have a lot of different functions surrounding the welding operation. So the solution is in generally focused on, let's say, a very important matter of fact, and here we are having a 600 millimeter diameter workpiece. We are talking about 130 kilogram workpiece weight, and we decided to have a very flexible machine. At the end, if we talk about very huge or large components, it is always needed to have a flexibility as well. So we decided to implement a flexible NC controlled optic, so you can easily switch the optics from a vertical position to a horizontal position, and for sure in angular everything in between. And we also decided, as I mentioned, pre-functions as well as post-functions surrounding the welding process. So from our perspective, we developed this machine about 4 years ago. We already realized several products, or let's say several solutions for products, especially for truck components, and therefore we do have an answer for heavy components in regards to the laser welding process. If we look into more details in regards to the process of a differential, then we definitely see that the welding process in general is, I would say, the heart of the machine. Nevertheless, we first of all have to clean the workpieces before. Therefore, we decided to have a laser cleaning operation included in the machine. Then we do have to turn over the workpiece to make sure that the components are in the right position. Then we do have an implemented pressing function as well. Here the request was having a pressing function up to 100 kilonewtons. And as a matter of fact, if we talk about huge components with high tolerances, then we have to make sure that the weld seam later on is always in the middle of the two single components, and therefore we are having an EMAG developed system, so-called EMAG EC seam, and this system is able to check the right position before we start welding. I will show you some details later on. And for sure, after seam finding, we do have our welding operation itself. So here we are having a solid state laser optic or a solid-state laser with an optic which is NC controlled, and we are also using shield gas as well as filler wire to realize that components. And for sure, last but not least, we do have our post-process inspection, meaning we first of all make sure that there are no spatters on the welded surface, so we are having an implemented brushing system, and afterwards we move the workpiece to an ultrasonic testing station which is controlling the workpieces 100%. This system is also developed by EMAG, software as well as hardware, and after we have checked the workpiece and it is going to be an okay one, then we move the workpiece out of the system. To start, and this is what I mentioned at the beginning, this line you see here is right now standing in our plant. We are close to having the pre-acceptance in our plant, so we definitely would have the chance within the next weeks to show you that line in reality. So therefore, again, feel free to ask us, and we'll try to organize a meeting in person. And what we see here is a fully automated system. We first of all having an in-feed conveyor with pallets on it. Then we do have two ELC 600 machines, two pretty simple. At the end, it was a question of cycle time, and therefore we decided to implement two machines with more or less the same content or functions included. We are having in front a huge double gantry system, which is also realized by EMAG, so it's an own brand. And this handling system is responsible for unloading the single components, moving it to the several function, and later on also to the outfeed system. As I mentioned, after the second welding machine, we move the workpiece to the brushing system and then to the ultrasonic system and then out. So just to continue, and this is something I will take the chance and give you let's say a small cut of the machine. I've mentioned previously that we are having several functions surrounding the welding process, and here we start again with the laser cleaning. So the interface of the machine is in front, so here the loading and unloading system is realized either by a robot or also by a gantry system, and then we first of all start with laser cleaning. Here we do have an laser scanner optics included within or behind the laser source. So here we first of all start rotating the workpiece, cleaning the parts, and then we move after cleaning the workpieces to the joining operation. Sometimes, and this is driven by the request of the workpiece or the material itself, we need to have an implemented induction preheating coil before, but this is always a question of if the material needs to have induction or not. If not, then we move the part underneath the joining station. We press the parts together, as I mentioned, up to 100 kilonewton, and then the workpiece is already in position, and then the optic is moving to the welded or to the welding position, and we start first of all finding the seam, and then we start with the welding operation itself. To give you a better overview in regards to the flexibility of the welding optics itself, we do have an NC controlled or more NC controlled axis included in the machine, and this is how we are able to realize different weld seams on one workpiece, or different weld seams on of a mix of workpiece variances. So you do have a very high flexibility in regards to your product, and therefore we have also implemented our EC seam system, and this is what I want to show you right now. If we talk about unique selling propositions out of EMAG, then I would definitely say this is one of them, because this is a system we figured out, and we started to develop that system several years ago, especially with the focus on passenger cars, and we figured out that it is definitely also a very important need for truck components. So what is the goal for that system? So we do have a very high precise definition of the joining position. Simply spoken, our goal is to realize a weld seam always in the middle of the two single components, and therefore we have this system implemented. So it's an exact guidance for the welding optics at the end, and this is NC controlled. So this product is, from our perspective, having several answers, and first of all we do have the situation or the possibility of a seam positioning control as well as a seam positioning correction, which is realized by an NC axis, and as an additional function, and this is something which is sometimes also needed from our customers, we do have a top bead control to evaluate the weld quality after welding. How does that system work? So first of all we start with a shot, so there's a camera system behind that, and we do a circular rotation of the workpiece itself without welding. So we scan the position with a camera, and this position is then being forwarded to the optics, which means we first of all start with the camera or with the system to start to find the right position, and then the position is scanned and will be directly forwarded to the NC controlled axis, which means later on the optic itself is able to move the optics NC control surrounding the workpiece to make sure that we are always in the middle of the two welding, of the two single components to weld it later on. The easiest way, as always, is to show you a small video. I decided to shorten it a little bit because the original length is approximately 10 minutes long. This will not be fit or will fit to our webinars. Nevertheless, this video was done last week on Friday, as I remember. So my colleagues have forwarded the video during the weekend to me, and I've implemented it directly into the presentation. So we now start by picking up the first two single components, load it into the welding machine, and then we start with the cleaning operation. As you can see, as I mentioned, it's a very short cut. But we first of all start with the laser cleaning operation of both workpieces. Then we do have an 180 degrees turning operation implemented in the machine as well to bring it into the right position to weld them. So afterwards we press the parts together up to 100 kilonewton. Then we start with the seam detection and then directly with the welding operation. As you definitely see, that was not a 360 degrees operation. This was just realized by our colleagues from the marketing to shorten the video in a defined way. So again, it is right now in reality available in Heubach, so we can also have a more exclusive look into the original line. Then we turn the workpiece back, go out of the system, and then the gantry is picking the first welded operated component and move it into the next welding machine. The machine itself is more or less pretty much similar equipped as the first one. So here we have loaded the first welded component, and then we load the ring gear as well. So the ring gear is now also being loaded, and then we start with the laser cleaning operation also for, first of all, for the cast component and then for the ring gear as well. So the idea is a turned workpiece at a fixed optic. Here we are using a scanner optic and a 200 watt pulse laser, and then we again move the workpiece up the ring gear, turn it 180 degrees. The cast component will be moved underneath, and then we load the parts together in the very right axis and position. Then again joining, and here we now see very nice how the weld seam detection is working. So now we had scanned the weld seam, and then we start with the welding operation itself. Here also shield gas is included, as well as filler wire, plus a very closed axiom extraction pipe to make sure that we are exhausting the whole fume during the welding operation itself. After we have welded the components, we move the part, as I mentioned, to the brushing station. So this brushing station is responsible to brush both weld seams, and again to make sure that there are no spatters on the welded surface. The final and very important process is now to check the quality of the weld seam. So here we are having an implemented ultrasonic testing station. Software as well as hardware is developed by EMAG, so we are able to integrate our own systems. So here we check in a very detailed way the quality of the weld seam, and if this quality is okay, we are allowed to leave the workpiece out of the system, again on a pallet conveyor system, and then our customer has later on implemented a robot cell to move the workpieces to the next operation. I now will take the chance, because I have seen a very first question on my tablet. So there was one question in regards to the cleaning process itself. Are different lasers needed for cleaning and welding? The answer is yes. So as I mentioned, we do have an 200 watt pulsed laser source for cleaning up the surface before welding. And in this special case, we are having an 8 kilowatt solid state laser source to weld the components together. So the answer is yes. Cleaning is done with a 200 watt pulsed laser with a scanner optic, and the second one is done with a solid state 8 kilowatt. What about the accuracy with movable optics? Wouldn't it be better to move the workpiece to the welding position? First of all, we do have NC controlled axis. So the optic is equipped with a lot of NC controlled axis to make sure that we are having a flexibility in regards to the angular. But wouldn't it be better to move the workpiece to the welding position? From my perspective, we do have during the welding process a fixed optic. So the optic is not moving during the welding process in an angular. We just move the optic in a very tight or small variance to make sure that we are realizing our ECC system. But in general, I would say there is no influence into the accuracy because the workpiece tolerances are allowing such kind of processes. What is the price of a full equipped like that? This is always a question I really like, but the answer is, as always, it depends. If I want to give you a feeling into this regards, such a fully automated system with 2 welding machines, high equipped with a lot of different functions, depending on the laser source, depending as always, but I would say approximately 2.5 to 3 million euro for the whole system, but we easily start with a manually operated machine, including laser source. I would say approximately 1.1 to 1.2 million starting at the very beginning. So it is always a question of how fully automated is it needed to offer, but at the end, this is exactly the right way. We ask you to have a very first meeting, and then let's go through the details, and then we figure out how a budgetary number could look like. So thanks for the questions so far. Feel free to continue with questions, and I want now to continue with the next slides. As I mentioned, I also want to have a small excursion to our heat shrink and joining technologies. This is not referring to a laser process itself. This is more a technology we are having in our plant as an available process to realize components instead of welding. And here we do have 2 very nice examples. So we are focused on truck components as well. So EMAG is able to offer also heat shrink and joining solutions, for example, for commercial car camshafts, or as well, something very important, assembled countershafts. So both parts you see here are assembled, so manufactured on EMAG heat shrink and joining solutions. To give you one idea, this is a very nice 3D screenshot out of a system we have delivered not so long time ago. It is now in final acceptance phase at our customer's plant. So this is a solution we have realized for that workpiece on the right side. So this workpiece is having several single components, and the request was to produce this part, which means to assemble this workpiece. So first of all, our job was to infeed the single components, meaning the gears, as well as the shaft components. So the single components of the gears are being preheated during the infeed process. So we make sure that the the temperature of the expected temperature of the single components has already been achieved when the workpiece is in the line. In parallel, we also feed the shaft component with a conveyor system into the line with an included cooling system. So we first of all preheat the single components of the gears and cool also the shaft to a defined temperature down to make sure that the wideness, so the tolerances, are perfectly fitting, and then the robot in that case is moving the single components into the joining machine 1 and 2. This is driven by a cycle time. So we start assemble the workpieces step by step, and then it is being cooled down, so then it's a shrink fit. So there's no laser process needed at the end. After we have assembled the workpieces, so the finished one, we leave it back onto a conveyor system, and here we have again a cooling system equipment to achieve the very right temperature. And then here it was a clear request to have a zero marking as a reference, as well as a measuring station or machine. So afterwards there will follow some further robot cells to move the workpieces to the next operations. This has been realized by our customer. But this is something I just want to share with you to give you a feeling that there is more, especially in regards to large components, and not just being focused on the laser welding process itself. The advantages of such kind of technologies are more or less pretty simple. At the end, it's a question of weight. At the end, it's a question of a comparison between conventional production and our system. So you do have the chance to use a hollow shaft component instead of a cast iron component with which is also having a higher weight. And if we continue comparing the advantages, then one of the very right answers is that you do have a higher flexibility. So you are easily able to produce different workpiece variances on the same machine without any manual changeover, because we are also having quite a lot of NC controlled axis inside. So the rate of a higher flexibility gives our customers a very good chance to change from type 1 to type 2 to type 3, you name it. And at the end, this is much more flexible compared to cast components, as one example. Now I see an additional question in regards to the heat shrink and joining solution. How do you ensure orientation and accuracy of the positioning of gears on the assembled gear shaft? Are the joint gears still welded afterwards? So first of all, to find the very right orientation between the single gears, we are having in every joining machine a possibility with sensoric as well as hardware, which is always controlling the position in between. So we are able to rotate the workpiece into the very right position before we start with the joining operations. So both functions are included in this joining machines. So this is how we make sure that we are always in a repeatable accuracy, and the parts are definitely not laser welded afterwards. So we are able to achieve these very high expected forces just with that technology. To continue and to build let's say a small bridge in regards to heat shrink and joining and laser welding is an additional one, also being focused on very large and heavy components, referring to agriculture solutions. And here we do have a transmission, which is first of all also having an assembled main shaft realized on an EMAG joining solution, as well as clutch components. Previously, we always had clutch components if we talk about passenger cars. And nowadays we also talk about clutch components for let's say large vehicles like the agricultural solutions, for one example. And the benefits are more or less the same as in a passenger car. At the end you do have less weight, you do have less space compared to conventional productions, and this makes it very interesting for our customers in their production line, in their way of designing new transmissions, and this makes it at the end very compact and interesting. So here we do have a solution focused on welding clutch components, and I am very happy to have the chance to use the same machines as previously in the passenger car solutions. So we decided to use our we call it a bread and butter laser welding machine, so-called ESC 160. This machine is being used for a wide variance of different technologies or processes. And here the request was to realize a machine with this kind of variances. So it was not just a request for one workpiece type, so the request was to have a flexible solution which is able to weld different workpieces in a mixed way, and the request was also without any manual changeover time. So we realized it, and this is the bill of process at the end. So we first of all start with loading manually the single components. It was a request driven by the workpiece material itself to have either preheating or post-heating implemented. In between, we start with the laser welding itself, which is also fully equipped with all the requested and needed processes surrounding the welding operation. And afterwards, we are able to load the workpieces out of the system. So again, also here a very nice cut. So here it makes it easier to have a more detailed look into the machine itself. So as you see, there is a slide underneath, and this slide is moving from step to step to step. So this gives us the flexibility and possibility to implement the very right functions. So at the end, you as our customer are able to tell us what else is needed, and then we are able to implement those functions into the machine. As you also see, there is axial as well as radial welding requested or implemented, so pretty much the same as in the truck differential project. So also here a very high flexibility is available, and therefore we are able to realize these very nice variants of workpieces. The answer also here in this regard is a short video. This gives us a better overview about that system works. So either we are having the possibility to implement a robot cell or a gantry, or also manually loaded. And if we start first of all, on the left side there is the chuck and the slide, which is NC controlled, moving underneath the different functions. So we first of all start with loading the two single components, and to make sure that the two single components are in the right position, we first of all press the parts together. Important to mention is that the chuck underneath is not losing the fit during the whole process. So we are always able to hold the very right position. So we first of all have assembled the workpieces, and then we start with the welding operation. Here, as in the most of the welding machines of EMAG, the idea is to have a moved workpiece, so a turning workpiece. The optics is fixed. The workpiece is completely covered during the welding process, so we make sure that there are no spatters on the workpiece surface itself. And then we move the workpiece to a next position. Here we have implemented a sensoric to measure or to control the runout. So very compact and flexible machine, and we always try to make it possible to fit to your requests. So this is, again, I would say our bread and butter machine, and this is our goal to at the end make it happen that we fit to your request. As a last technology which is also being focused in regards to laser, but in that case not in regards to laser welding. This is more referring to a laser cleaning process with the focus on laser cleaning, and not as a typical preparation for a welding process. So laser cleaning from EMAG, we do have our own developed systems. So we do have indexing table machines as well as the equipment to implement it into a welding machine or implement it into another solution or another machine, always with the focus on a kind of preparation for, in that case, downstream process as one example. We are going to prepare the workpieces for the welding process, and in today's special request we are going to remove the paint from a wheel hub also for a truck. So first of all, how does the laser cleaning process work? So from the technical standpoint, this is referred as a so-called laser ablation process, and we make sure that at the end, for example, there could be an anti-corrosion surface like a liquid, like oil or something like this, and this has to be removed. Or in today's special case, we do have a very nice wheel hub, and this wheel hub is having a black color painted surface. In German it's so-called a KTL surface. And this surface has to be removed in a defined area in which later on a bearing will be pressed. And therefore it was requested to EMAG to remove this color in this defined area. So we decided to offer our laser cleaning machine, so-called LC8, which is referring to the size, and the request was to clean those mentioned wheel hubs with a diameter up to 450 millimeters. And very challenging was that the request was to realize in total 35 different variances. And this is always a challenge to realize a system without any manual change over time, and therefore we decided to use an indexing table with in general 4 stations, but always just 2 are in process. And depending on what kind of workpieces are coming into the system, we move from fixture A to fixture B, and therefore we have been able to realize these 35 variances. To continue in regards to the process, we do have 2 300-watt pulsed laser sources to achieve the expected quality. We do have an automation front up which is responsible to turn over the workpieces 180 degrees, and for sure there's also an interface for later on a robot system which is then responsible for loading and unloading the components from the pre and also post functions, but this later on is realized by our customer. An additional very important function which is implemented in that system is our so-called EMAG EC Clean software. So this is a software developed by EMAG which realizes to control the quality or to control the cleaning process during the cleaning operation itself. So it's also a camera-based system which is looking onto the process live, and this gives you the possibility to check at the end the quality and to ensure that there are no failures during the process itself. How does the machine or the system look like? On the left side there's a picture from a real laser cleaning machine. In that case, we have used this laser cleaning machine for preparation for welding. Nevertheless, the function is at the end the same. And on the right side, you again see the the cleaning machine in a more detailed way. If we open the doors or remove the blank sheet metal surrounding the machine, then you see the more important details. So we do have implemented 2 horizontal NC control axes with 2 cleaning optics, and all of those functions are again NC controlled to realize or to let's say to have at the end a very high flexibility to bring the cleaning head always to the right position in which we have to clean. And this gives us also a better idea. So our job was to clean the surface on or in the inner diameter. So first of all in the upper side or on the upper side, then we turn the workpiece 180 degrees, and then we clean the surface on the other side, also in the inner diameter as well. So therefore we decided to implement 2 cleaning optics to also achieve the cycle time request at the end. So the principle is the same. We do have a moving or a turned workpiece. The optics is fixed. The optics is also a scanner one, so it's having an area of 100 to 100 millimeters. And here we do have also our own developed software. I now see a question in regards to a previous welding process. Excuse me, I was maybe not able to mention the question in the right time. Excuse me for that. Nevertheless, I try to answer the question right away. So do you need additional material to weld ring gear on differential case? The answer is yes. We have implemented also an filler wire, which is directly implemented in the machine, and this filler wire is used as an additional material to achieve at the end a qualified weld seam. Do we need to remove hard material before welding? The answer is also yes. If we do have a hardened layer before then we normally are using an turning operation to remove the hardened layer to make sure that we are able to weld in the expected quality. And now our colleagues from the marketing team have forwarded me the next question in regards to the laser cleaning process. Does the cleaning process have negatively effect into the surface? How cleanly is the paint removed? Do residuals remain here? Three questions, three very important and good questions. So first of all, it is having indeed a negative effect if you are not able to hold to hold a stable process. To give you a very good feeling, this is a very nice picture. In this regard, so if we turn the workpiece and we do have a scanner optic which is cleaning the surface, the optic is also moving, also in a vertical position, which means we are always having a kind of overlap in between. And the challenging request is to make sure that in this overlap area will be no heat affected zone, so that we are not having a thin hardened layer in between. And the answer is we have realized that at the very first testings, and then we started to figure out how to make sure that this will not have any negative effects. And the answer is we decided to have an own developed system in the software, and this software is able to move the optics or the laser at the end in a very defined way to make sure that there will be no overlap in between, to make sure that there is no heat affected zone in between. How cleanly is the paint removed? At the end, it has to be removed as our customer is requesting it for. We first of all started also here with this workpieces with a 200 watt pulse laser. We figured out that we are able to realize it, but unfortunately not in the expected cycle time, and therefore we decided to increase the laser power itself. So we decided to implement a higher pulse laser source, and therefore we ended up at 300 watt, and that was the reason or the way to achieve the expected quality. To continue, and this is something I want to end up with the laser cleaning. At the end, it is having definitely tremendous advantages compared to so far conventional washers, for example. If you compare a 3-zone washing machine, which needs definitely much more space compared to a very compact laser cleaning machine, it is environmental friendly as well as very important if we talk about maintenance. So you do not need to have any washing liquids, you do not need to have water at the end, and from the maintenance perspective it is definitely much more friendly in compared to that. And at the end you achieve other processes with a laser cleaning machine instead, because here we are able to remove phosphate, here we are able to remove also color or paint, and this is at the end something which makes that kind of system unique. And I repeat myself, we are either able to co-oat machines itself, also are able to just co-oat, let's say, the cleaning process itself, which is referring to the laser source, cable, as well as optics, including the software. And this also can be easily implemented into a fully automated system. One additional question. Just try to switch in between the camera as well as the tablet. How do you protect the welding optics from splashes and smoke? I assume that this is something which is referring to the previous welding processes. So first of all, our idea is always to have an completely covered workpiece. So we are using a so-called, we call it welding mask. This first of all is making sure that the workpiece in general is covered, and we just have an open area on which we are going to weld the two components together. The second answer is having a brushing system afterwards to make sure that there are no spatters on the surface. And regarding to the welding optics, we are having shield glasses in front, which is more or less standardized components from the optics supplier. And for sure, also something very important is the X-film extraction to exhaust the fume during the welding process itself, which makes it easier in regards to the protection. And next question, what flexibility does such a system offer? Can different differentials be welded? How does the retooling look like? In general, our goal is to offer you a flexible machine which is able to realize different products on the same machine without any manual changeover. Meaning the idea is to have I assume I mentioned that sometimes, so we do have an NC controlled optics also with an NC B axis. This NC B axis is also having an beam guidance included, and this is giving us the possibility of realizing and welding different products, different components on the same machine without manual changeover. The only thing what you have to change is the NC program of the machine itself, and this can be either done manually by changing the software, or also if you do have a checking station in front which is checking the right workpiece, and this is then being forwarded to the welding machine, and then the welding machine is able to adjust itself and to continue with the new product. Will the seam be machined after welding? If we are focused on the truck differential I have shown previously, then the answer is no. Normally it is not needed to machine the surface after welding. We just brush the welded surface. If we talk, for example, about rotor shafts, which is also something very important for our business, and rotor shaft for an e-drive is normally welded and afterwards then again turned or grinded to achieve let's say at the end an round and expected qualified workpiece. So both is possible. At the end it's a question of where will the workpiece later on be assembled. So is it needed to achieve a higher quality, or is it enough to have the welded seam implemented in that system? Laser cleaning, is it enough to remove oil? The answer is yes, if the oil is used as an anti-corrosion surface, just to make sure that there will be no rust, then it is a kind of thin layer, and this thin layer can be removed with the laser operation. If you do have let's call it complete wet oil workpiece on which you can see drops going down, then I would definitely say this is maybe a little bit too much. But in principle, if it is a kind of oil spray or something, this can be easily removed with the laser cleaning, yes. No further questions so far, as I can see. This gives me another very nice opportunity to continue with from my perspective, very important slide. At the end, laser processes in general, either laser cleaning, laser welding, laser hardening, laser metal deposition, so on and so forth, always need at the first step process development. So we figured out that it is very important to have the availability or the possibility to offer this to our customers to support in a very early stage with process development. For sure, our goal is also to have the possibility to produce prototypings as well as small volumes, and therefore we are I would say very nice equipped in Germany in our facility in Heubach at EMAG Lasertech with one application lab. We do have an additional one in China and the third one in Americas, which means close to Detroit as well as close to Shanghai. And all three laser labs are, let's say, having at the end the goal to support our customers in a very early stage to do the prototypings. And as you may see here, we are very nice equipped. Finally, especially in Germany, we are having 5 or 6 different laser sources. So we are talking about pulsed laser sources, we are talking about solid state lasers with fiber, we are talking about CO2, but also about diode laser sources. So we are able to offer all the needed functions surrounding our laser processes, and not just welding, also, as I mentioned, cleaning, hardening. We are also equipped with ultrasonic, so on and so forth. The reason why I mention this, I definitely want to take the chance and invite you also to involve us in a very, very early stage, to give us the possibility to have some positive influence into the workpiece design as one example, to do some testings, to do cuts, to polish the surface, to figure out if the weld seam, for example, is in the right defined area, so on and so forth. So this is something I definitely want again to point out, and in combination with the invitation of a visit in our facility to may have also a more detailed look into the truck differential line, I think this is something which is having a very nice chances, and therefore feel free to push me, to ask me, and to figure out if we can meet us in person very soon. So far I can't see any further questions, and therefore I wanted to take the chance, because I'm finally at the end of my presentation or of my webinar, and yeah, I want to thank you for joining, for listening. And I am also going to answer if there are some further questions open later on by email. And yeah, thank you very much and take care.